into the mix here. So let's bring snow into this. So we'll have rain, snow, and sun. And let's suppose the following things. Let's suppose that it is, I want 4 times as likely I'm going to write it this way. My grammar is bad. It is, yeah, okay, 4 times as likely to rain tomorrow as it is to snow. And also it is 2 times as likely, it's twice as likely to be sunny tomorrow as it is to snow. So both rain and sun are more likely than snow, 4 times more likely to get rain than snow, and 2 times more likely to get sun than snow. So again, I could just ask, what are the probabilities of each? And I claim I've given you enough information to figure this out. And I'll show you how. It'll be much like the last one. We just have a little bit extra data to take care of. Because now there's 3 weather types instead of just 2. So what are the probabilities that each one happens tomorrow? So I would start this problem exactly the same way that I started the last one, which is by introducing variables for these probabilities that we would like to know. So, you know, let's assign X to rain, Y to snow, and Z will be sun. So that's the only difference here is now I need 3 variables instead of 2. But again, these represent probabilities. So when I say rain, I really mean probability of rain, probability of snow, probability of sun. Okay, these are probabilities. So given that they're probabilities and they sort of exhaust all the possible outcomes in this scenario, what do I know about them? What's one equation that I get for free? Well, I know for free that if I add up all of these, I'm going to get 1, right? So if I do X plus Y plus Z, I have to get 1 because these are the probabilities of all the possible outcomes. And so when I add them up, I get 1. Okay. Now, what's next is I need to get more equations. I mean, this is one equation with 3 variables. I can't solve this willy-nilly. I need more equations so that then I can solve a system. So I need to use this other information that we're given. So for example, I need an equation that represents this statement about it being 4 times as likely to rain as it is to snow. And I need an equation that represents this other statement that says it's 2 times as likely to be sunny as it is to snow tomorrow. So I need to translate those into math using these variables. And it's just like last time. This 4 times as likely to rain tomorrow as it is to snow is basically going to tell me that X is equal to 4 times Y. And this one is going to tell me that Z is 2 times Y. So my system of equations is the following. I have X plus Y plus Z equals 1. I have X equals 4 times Y, and I have Z equals 2 times Y. My system of 3 equations with 3 variables. Okay. So now to finish off the problem, I just have to solve the system. So again, our tools from chapter 5 way back at the beginning of the semester come into play, and we just have to solve a system of equations to answer this problem about probability. So again, these are really nice. They're sort of set up for substitution. So I would just substitute these into this first equation here. So substitute 4y for x, substitute 2y for z. I get this. Now everything on the left-hand side has a y in it. So I'm going to collect the like terms. I'm going to get 7y equals 1. And so divide both sides by 7, and I find that y is 1 over 7. Y is 1 over 7. Again, just to check, that is a number between 0 and 1. It's between 0 and 1. So that makes sense as a probability, so we're good. And so now I'm just going to plug this back in up here and find out what x and y are. So x is 4 times y, so that means x is 4/7. And z is 2 times y, so z is 2/7. And now I'm done. These are my 3 probabilities. So the probability of rain is 4/7, the probability of sun is 2/7, and the probability of snow is 1/7. Okay. Okay. So this is how we can use the fact that if I take all the possible outcomes and add up the probabilities, I get 1. We can exploit this to solve problems where maybe I didn't explicitly give you a probability, but now I can conjure up these other equations and solve a system to find out the individual probabilities. So again, if you look on activity 8.1b, there are a few problems of this style. So use these couple examples I did as a guide to solve those problems. Cool. So anyway, are there any questions?